Okay, so here we go. Now we're going to use everything we've learned about similarity and congruence of triangles and be able to solve any problem that they throw at us. One thing you want to do at this point, because our test will be coming up right after this lesson, is make sure your cheat sheet is all filled out, that you have all the theorems like the triangle bisector theorem and all the other things about similarity, AA, SAS, SSS, all those things. So if you haven't filled yours out, make sure yours is complete because you can use that on the test. Okay, here we go. Let's draw some pictures and find some similar triangles. If a meter stick casts a shadow that's 65 centimeters long, at the same time a tree casts a shadow that's 2.6 meters long. The question is, how tall is the tree? Let's get some pictures drawn and then we'll come back and find similar triangles. Okay, I have my meter stick and its 65 centimeter shadow, and the tree, whose height I don't know, that's what we're looking for, and it's 2.6 meter shadow on the ground. And of course they are similar triangles because the sun is shining down towards the ground at the same angle for both straight up items. Okay, I'm going to change to centimeters. You could just as easily change everything to meters, but I'm going to change to centimeters, and then if the question asks how tall is the tree, I'll probably change it back to meters. So an appropriate similar triangle would be matching height to height. So we could go 100 to X and shadow to shadow, 65 to 260. Do your math and you should come out with 400. X is 400. Now that's in centimeters. I'm going to answer it in meters now, so I'm going to divide it by 100 centimeters for each meter, and X will be 4 meters tall. That's how tall the tree is. Example 2, finding the distance across a canyon could often be difficult. I'm not sure who comes up with these problems, but this one does make sense. A drawing of similar triangles can be used to make this an easier task. Use a diagram to determine the length of AR, which is the distance across the canyon. We will want to write out our matching sides of the triangle, so I think to do that, to be helpful, let's look at the two triangles and name them first, because remember, lots of times it's so much easier to look at the lettering instead of trying to look at the picture. Notice I drew in angle A and angle C because those are both the right angles there, and then B is marked the same on both sides. So by AA, we definitely have similar triangles. And here is the name of those two triangles. We could name it triangle RAB is similar to triangle DCB. And then looking there will help us find matching sides a lot quicker. Okay, we know we want to use X, so I'm going to go with the X to 75. Those are matching parts, and just to double check what those are, that is RA to DC, and then 180 to 90. And 180 is length AB, and that should match up with CB, and that's correct. Do your cross products, solve for X. I'm not even going to show all the math. Comes out to be X is 150 meters. Now double check if that's what we have solved for. If what we have solved for has answered the question. We have an X to represent distance from A to R, and that's exactly what they asked for, the distance across the canyon. Example 3. Here's another great problem that I'm sure we'll all run into, measuring across a pond, but even so, it's still a good example of using similar triangles. In this case, it's the 3 right triangles within each other, so we want to write out our small, medium, and large, draw them out so that we can find matching parts. I know already that it's going to be the small and the medium triangles we need, so I'm going to draw a small triangle CDB, and let's get the 30 and the 12 on there. Also, the fact that that's short, long, and hypotenuse. The medium triangle, if I stand this one up on its side so that it's turned the same way as the way I drew my small one, This would be D, C, and A. There's the 30 feet and X. Hypotenuse, short, and long. Okay, you can probably tell already that we have the pieces of information we need. Let's write out a proportion. Let's go short to long. That would be 12 to 30 on the small one. Matches to 30 to X on the large one. Do your algebra. X will turn out to be 75 feet. Once you have found that, double check that that's the question that was asked. The question is, what was the measure of AD, the distance across the pond? And AD was represented by X, so we have found it. Okay, in example 4, they want us to estimate the height of an overhang. This would be like an overhang on a house or something. So this whole distance right here is the actual overhang. So the surveyor is going to stand so that her line of sight, this would be a person standing here looking, forms a right angle when she looks up to the top and down to the bottom of the overhang. So you see the right triangle, which is formed triangle ABC with a right angle at C. The question is, what's the height of the overhang to the nearest tenth of a meter? So to find that, we'll need to find the length BD first so that we can add from B to A and have the entire length of the overhang. So I'm going to go with the small and the medium triangle again. The small triangle would be drawn out. Should have given myself some more room. D at the right angle, A and C. Here's short, here's long, here's hypotenuse. And let's put some numbers on there. Short is 1.75 meters, and the long is 8.5 meters. Okay, let's draw the medium-sized triangle. That would be triangle BDC. Whoops, not a very good drawing there, but there's D. That's why labeling helps. And the short leg is 8.5 meters on this one. That's the short. The long leg is X, and the hypotenuse we don't have. But as you can tell, it's going to be short and long that we're going to match up. So let's write our proportion. I did that wrong. We want to say short leg to long leg. For the small triangle would be 1.75 to 8.5. That matches with 8.5 to X in the medium triangle. Do your cross products. And X should come out to be approximately 41.3 meters. Now, take a look at what you have found. You have found X. That's 41.3 meters. We've rounded that to the nearest tenth. That is the length from B to D. The length of the overhang, or the height of the overhang that they ask for, is the length from A to B. So we need to take our 41.3, add it to the 1.75 for the bottom part of that, and you get a total of approximately 43.1 meters for the height of the overhang. Okay, there'll be lots of other drawings you'll make, and the main point is to always find similar triangles and match up similar parts so that you can solve for any missing sides. You should have a test coming up. Don't forget, you should have all late work turned in before the test so that you're successful on the test, all of your notes completed, and make sure you do have that cheat sheet filled in because you can use it on the test. Good luck.